we want to look at rates of change, and the example that we want to discuss is water is poured into an inverted circular cone of base 5 centimeters and height 15 centimeters at the rate of 10 cubic centimeters per second. So find the rate of increase in the height of water level, and 2, the rate of increase of the water when the water level is 4 centimeters. So if you look at the solution, we are saying that let the water level be h centimeters after t seconds, and the radius be r centimeters as shown in this cross section. So we have the water after time t to be h centimeters high and the radius to be r. So the inverted circular cone is of base radius 5 and height 15. So we consider the similar triangles. Consider the similar triangles, triangle OAB, and the other one is triangle OA prime and B prime, OA prime, B prime. So those two triangles are similar triangles. And then we can see that using the similarity of those two triangles, we shall find that r over h is equals to 5 over 15. Why are we saying that? Because when we talk of similar or similarity, the ratio, suppose we have this point here as x and this one x prime. If you use the linear scale factor, we shall know we have that OX over OX prime is the same as OB over OB prime, okay, and is the same as XB over X prime B prime or X prime B prime. So those ratios are the same, and therefore from here we can say that the small r is the same as 5h over 15, 5h over 15, which is the same as h over 3, because you can say by 5 1, by 5 3. Now we know that the volume of a cone is given as V for volume is equals to a third pi r squared h, pi r squared h. So we can put r, we know r from here is h over 3. So it means then volume will be a third pi. So instead of having r squared, we shall have h over 3 squared h, over 3 squared h, and this will give us a third pi h cubed over 3 squared, and this we can still write this as pi h cubed over 27, pi h cubed over 27. Then from here we can ask ourselves, what is the change in volume with respect to height? That is dV dH, change in volume with respect to height. So you differentiate our V, which is pi h cubed over 27. And this one will give you 3 pi h squared over 27. 3 pi h squared over 27, which is the same as pi h squared over 9. The change in volume with respect to h will be pi h squared over 9. But we can say that change in volume with respect to time, because we want to see what is this rate of change. Change in time, change in volume with respect to time. If we use the chain rule, this will be the same as change in volume with respect to height times change in height with respect to time. Change in height with respect to time. But we know that from what we are given is that the height, the water is poured into an inverted circular cone of base 5 centimeters and height 15 centimeters at the rate of 10 cubic centimeters per second. So we can say that that change in volume with respect to time is 10 cubic centimeters with respect to, per second. And we know that at this point, the height or the water level is 4 centimeters. The water level is 4 centimeters. So therefore, you can say H is 4 centimeters. 4 centimeters. So we can say then that we can say 10 is equals to pi. Remember, this is pi h squared over 9, which is the same as pi 4 squared over 9. Note that this is change in volume with respect to time, and then times change in height with respect to time. Change in height with respect to time. And this will give us, this implies that change in height with respect to time will be the same as 10 times 9 over pi 4 squared, or 16 pi. And if you simplify, you'll get 45 over 8 pi. And this is centimeters per second. Centimeters per second. Okay, so that is the rate of increase of the height when the height is 4 centimeters is 45 over 8 pi per centimeters per second. Centimeters per second.